But I think there's like some kind of super general approach that we can start taking, where like you could imagine, like right now you have transformer blocks in computer vision and in NLP that are network architecture that's seemingly able to model everything. You could see a world in which, research gets better at solving like the catastrophic forgetting problem, and you can start to store all this stuff up in one shared set of weights that can be modulated for different use cases and stuff. And so then it just gets more and more general. But I think there's always people who are like applying it and wielding it. I think that's the one thing that's different about the GPTs and stuff, is that it's still very much input-output, and the developer is integrating it into something if it's actually getting used. And I think that's just going to be how it always is, where there's developers that are integrating data flows. And I just don't see something that's like coding itself, performing actions of its own initiative.
Welcome to the Conversations on Applied AI podcast, where Justin Grammans and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Jacob Solawetz. Jacob is a machine learning lead at RoboFlow, where he's developing and scaling computer vision using AutoML model training and deployment. Prior to RoboFlow, he was a senior quantitative associate analyst at Travelers. He also holds a bachelor's degree from Washington University in St. Louis, where he majored in mathematics, economics, philosophy, and computer science. And that's quite a range of things to be studying, so very impressive. I love it. Welcome, Jacob, and thank you for being on the program.
Yeah, thanks, Justin. I'm really excited to be here. And yeah, pretty wide range of academic interests, but I promise they've all been relevant today.
Good. Yeah, I went to Augsburg College, liberal arts college here in the Twin Cities. And so I love just this full range of education, because, there's definitely a lot of overlap. And today I'm super excited as well, because I'm very interested in computer vision and its applications in all sorts of areas in the real world. And I have a startup that I co-founded. It's called Captivation, and we're using audio and video to help people become better communicators using online presentation tools, right? So getting a chance to see how people, not only how their facial recognition works, but also how their voice and speech works to improve their presentation skills. So I'm very interested in what you've been doing at RoboFlow. Specifically, I know you guys are deep into this space, but also in your career. So maybe give a little bit of a short background on how you got to where you are today.
Yeah, certainly. Like Justin said, I studied math and econ at WashU, and I really got interested in quant trading and started to write some algorithms on trading in the markets. So I was across various asset classes, and bonds and stocks were kind of where I started to focus and kind of where I started my career off. And then through the process of learning quantitative finance, I really got interested in the machine learning side of things. So by the end of my college career, I knew I kind of wanted to shoot towards an AI PhD. As I was working on quant strategies, I was also doing AI research in my nights and weekends. And then that led me into an NLP PhD, where I was working on chatbot research and designing conversational dialogue systems. It was actually pretty similar to what RoboFlow is today, where we had some kind of platform where there was ensembles of neural networks underneath, and then you could kind of load in custom data and then train from there and kind of fine tune into a particular domain. So the way that it works with chatbots is the exact same way that it works with the computer vision models. And so I got some good exposure there and had an opportunity to join some of my friends early on the RoboFlow venture. And I took the opportunity, and ever since has been history. Just been focusing on computer vision models now.
That's awesome. Yeah. And if you check out RoboFlow, maybe you can give us a little bit more details on exactly what you guys are doing. But it feels like you said, this ensemble sort of training machine, right? You can feed it a bunch of images in particular and sort of classify them, and then it will start using all that data to start making predictions as new images are fed to it.
Yeah, that's right. Yeah. So I guess a quick summary of what the RoboFlow platform is it's a place where you can load in image data, annotate that data. Traditionally, the way that we find most users getting value from that is in object detection. So just kind of labeling bounding boxes around the objects that you want to detect. And then you can create data set versions from those annotations, and you can try different things like different augmentations and pre-processing, which edit the way that your data set is formulated and the way that the images are formed before you pass them into training. And then you can kick off training on the back end and then get inference back on a hosted API. So you can kind of go through this whole process again and again easily as you're adding images. And so the biggest kind of philosophy of RoboFlow that I think is true in the AI landscape at large today is that data sets are mutable. And if you're doing anything in production, if you want to be debugging your machine learning models, you're going to be iterating on your data set and continuing to publish new versions of your model and really fine tuning into the domain that your model is working on. So that seems to have played out as a need developers and machine learning scientists have. And then the other side of things is that RoboFlow has been expanding the horizon of people who can actually use computer vision and deploy it into their applications. So you no longer need to have a PhD in computer vision to start making some of these state-of-the-art models, because you can just use a service like ours to sit on the shoulders of giants and use some of the best open source research that is out there.
That's awesome. Well, I think I saw, were you employee number one, I guess, when you mentioned early days?
Yeah, so I was employee number one. I was technically, I don't know what my title was, but I think it was like technical generalist or something, but I did all kinds of things like marketing and customer success, and as well as ML engineering and kind of working on the product side of things, which is now my primary focus. So I'm now abstracted a few layers away. I still go on sales calls and things, but yeah, a little bit deeper down in the weeds.
Sure. You got to pitch in everywhere you can. I've started a number of different companies, and yeah, people wear all sorts of different hats. You had mentioned working on like a PhD in AI, right? So what could have sort of got you away from, I guess, the research side into a business? Is there anything?
Yeah, definitely. So, I mean, when I was shooting towards an AI PhD, I always had the idea of starting an AI company afterwards. And so when I started my PhD, it was at Michigan, and I was working on a company called Plink at the same time. So I always kind of had one foot in the startup world, if that makes sense. And then, when coronavirus hit, my lab was going entirely virtual. I actually don't know if they've still met up yet. A good friend from home was wondering if I wanted to, they had gotten accepted into Y Combinator. And it's like, oh, do you want to move in and start working on the startup together? It seemed like a better option, at least in kind of my micro lens for my life. In a macro lens, I was definitely headed towards PhD and AI research.
Gotcha. Is it something you think you might go back to someday, or you feel like you're getting so much information and so much knowledge right now, just being out and submerged in it?
Yeah, definitely. I kind of think of my career a little bit as like a gradient descent towards AGI in some sense. You kind of be one thing that gets closer and more general, and one thing that gets closer and more general. But there's a lot of things about this viewing industry now that I'm finding a ton of value in, which is one, keeping the problems real, and then also this kind of feeling of having a user base that's pulling things out of you and kind of trying to think about an idea as larger than your own sense. The other thing is there's a lot of problems with the academic research world as it stands in AI, and I'd be happy to, if we wanted to go down that rabbit path, get into that. But yeah, I think places like RoboFlow is a very interesting place to get exposure to a career in AI, but also there's things like OpenAI too, where there's these kind of really cool initiatives that are forming where you can get alternative exposures to the field. There's really not that many professors out there too. That's the other hard thing. A lot of people who are listening to this podcast, I'm sure, will be thinking that as well. So.
Sure. So yeah, you have all these images. I guess when I think about then it's the tagging and labeling of them that can be a monumental task for some of these companies. Is that true? Or like what are some of the barriers as people start using RoboFlow?
Yeah, labeling a really large data set can be a really slow thing. There's different approaches you can take to like the labeling size. So there's automated labeling. When you train a model, you can use the model to label and then just kind of edit from there, which lets you get kind of more intimate with your model then, because you have to watch it, infer, correct it, watch it, infer, correct it. But it also speeds up labeling. And then there's other automated solutions like Amazon SageMaker, and you can use things like Scale AI is a really good like mass labeling platform. And the solution there too for us in most cases is if we don't do something extremely well, we just integrate with people. So you can load in scale annotations of the RoboFlow. The other side of it is a lot of just like problem scoping. A lot of problems now are tractable with pretty small data sets. And so if you can scope your problem and chunk it down and kind of limit the domain that your model has to span, you can limit data set sizes. But it's always different for every problem, and more data is always better.
Sure. Do you guys do anything with like transfer learning? Like, can I bring in a model from something else and apply it to a different business use case?
Yeah, so this is actually kind of a cool transition to talk a little bit about maybe RoboFlow Universe as well. But yes, so checkpoint trading is supported. So if you have a version that you started with, you can take that version and start on a new thing. So maybe if you want to detect people, it might be a good idea to start from the Cocoa checkpoint, which is a big open source data set that Microsoft released, and it has a lot of people in it. So you already start from a pretty good base if you start from that model. Now, you can't necessarily import your model in from elsewhere because you can imagine for my side, that'd be very difficult to get all these frameworks to play with each other and different checkpoints to play along. So it has to be trained within RoboFlow to do the checkpointing. But now the other interesting thing that we're working on is this RoboFlow Universe concept, which is a public repository of data sets. So now you can come into our application and you can make a data set public and use a lot of our features for free if you're willing to make your data public. And we found what's a kind of a nice bifurcation between the communities that use our platform, which is there's a lot of students and hobbyists who are completely open to that idea. And then enterprise clients need their data private. And so they've pretty much self-selected themselves into that private area. But the cool thing about that is that we're accumulating a massive data set of data sets, So it's like we've got over 20,000 just different data sets or so. I think it's like 400 million images or something like that now. So you can start from all those public checkpoints too. So also another one of our theses is that there's a lot of these models that are going to be redundant. So you won't even have to make your own model. So there's like a playing cards model on RoboFlow Universe where people are inferring against it who didn't even train it. And that's kind of the end goal where we want people to get to, where developers can just pick up an API that they want to use. If it's detecting playing cards, then maybe they can just pick that API up. They don't have to even pipeline anymore. You can just abstract the whole thing.
Totally. I think that's really going to help advance, I guess, the power of AI. And it's kind of the beauty of open source just in general, right? Everyone's been able to, as you said, stand on the shoulder of giants. And if people build these models using data that I'd never have access to, for example, then we can do some really cool things together. And, there's a lot of compute that goes into building these models too, right? Like, why would you have to or want to, or just a lot of energy, just electricity that goes to make these models. So why sort of reinvent the wheel on that, right?
Yeah, certainly. No need to spin GPUs necessarily.
Have you heard of Teachable Machine?
I haven't.
Oh, okay. It is a sort of thing where you can actually train pictures of various things. And, you can send in pictures of cats and pictures of dogs, and then you can show it a picture of a cat or a dog, and it will go ahead and, show you what's there. And you can actually export your model then out into like a TensorFlow model that you can then apply somewhere else. Are you guys able to, again, kind of diving a little bit more into RoboFlow, but we can get on to other things. But I'm just more or less curious, can you export your model at all out of this stuff?
Yeah, so this Teachable Machine seems pretty similar to what we're doing. We do image classification too. Exporting is kind of always a little bit of a sticky topic, or uncertainty about the long story. If you allow people to export their model, they can sometimes just kind of run away from the platform, or they figure out how to train a similar one, and then they just sort of run away. And we're trying to kind of sell it more as a bundled package. So a lot of the deploy offerings are actually abstracted. They're swallowed by Docker containers that you can stand up. Because the thing there too is then you have all the installs as well. And that you can have just a little server that spins up that runs your model for you. And so you can completely abstract it away. Because if you just get a weights file, you still need to build TensorFlow. You still need to deploy the server. You maybe need to make your own Docker service surrounding it. And so we try to just kind of give you that whole thing. And then you can just have the full server. And you license that to run your model.
Sure. And like you said, these models need to iterate. They need to grow over time. And Teachable Machine is really something I just think for people to see the power of what you can do with just a few images. And that's just like what's really cool. And I'm actually reading a book right now. It's called 1,000 Brains. And it's by the guy, Jeffrey Hawkins, I think is his name. But he basically was the guy that founded Palm and started working on the Palm Pilot. And what's really interesting about the book is he really talks a lot about, as a human, there's a lot of predictive things that your brain just automatically does for you, right? If you were to reach over and grab a coffee cup, there's a certain sense or a certain feeling that you expect to have happen to you. And when that doesn't happen, then it's like, oh, I need to move my hand, or this doesn't feel right, or it's hot, or it's cold, or whatever it is. And so this whole idea of prediction and different types of ways that our brains work, and it's all biochemical type stuff, right? That's basically going on. But there's neurons and chemical reactions that are happening in our brain very similar to what would happen in a neural network. And it's been really, really cool to see the research that's been happening on that. But where's my brain going with this? Well, it's really kind of going back to, I think, this idea that you can't just create a model once and then be done with it. And so I think you guys provide a lot of those tools, right? To say, I have more data to feed into this system. Let's add some more to it, make it better.
Yeah, definitely. And just really focusing on the data set. Just put the data set first, That's kind of the biggest thing, I think, is applying these things is usually to think of the data set first. Unless you're working on some really, really general technology, most of the time it's good to just kind of find a model pathway that makes sense and then focus on the data.
Yeah, for sure. How would you define artificial intelligence?
That's a good question. I guess I would define artificial intelligence as teaching of machines concepts that humans can understand well, and sometimes maybe even exceeding human level of intelligence with the thing that you're teaching it. And I did kind of a YouTube recently that has kind of some of these ideas here, where people have been asking me on Airflow what the difference between machine learning and AI is. And then and then I also hear computer vision, and sometimes I think all three of these are interchangeable sometimes. But the way in my mind you have it right now is you have AI, which is the very broad umbrella, machine learning, which is also very broad umbrella that includes things like computer vision, NLP, so images and text, but it also has things like ASR, so with speech waves, and then all kinds of other data inputs that you could be putting in. But images and text are kind of the primary focuses right now. There's definitely other data pools that are getting processed. So yeah, so machine learning and AI span both images and text, but then for NLP and computer vision, you have those specifications. And then the difference between machine learning and AI is that AI tends to mean things that are a little more general now. Things that are AI now will be machine learning in a few years. And then as the horizons grow, AI will kind of be this term that keeps kind of occupying the horizon of things. So I guess what that means in application now is you can use AI technologies when you're using more general models, like if you're using BERT, or if you're using CLIP, which is a new one in computer vision that connects images and text. If you're doing anything zero shot where you're predicting from just no training at all, that in my mind is you're using AI. And then if you're fine tuning something in with kind of narrow domain specific data sets, that's machine learning. And so machine learning would be object detection, image classification, slot value pairing, text classification, question answering, that kind of stuff where you feed in a custom data set and it's the pipes are already kind of running. That's machine learning in my mind. I guess the other difference too is you have unsupervised and supervised. Unsupervised is AI, but obviously, that's kind of a tricky term because even these unsupervised models are supervised in a way. It's just they get to say unsupervised because they use a huge data set that they don't need to annotate. But the model of training is still supervised. So I don't know if that was, I kind of went on a tangent there.
Well, you did get me thinking then just about artificial general intelligence. And the other thing I like to talk to people a little bit about is, do you think that's possible?
Yeah, I certainly do. I think the definition is a little bit difficult. What exactly is this thing? I don't think there's something that just runs itself. I think the intent stays with different humans, but I think there's some kind of super general approach that we can start taking where you could imagine right now you have transformer blocks in computer vision and in NLP that are kind of a network architecture that's seemingly able to model everything. And so you could see a world in which research gets better at solving the catastrophic forgetting problem, and you can start to store all this stuff up in one shared set of weights that can be modulated for different use cases and stuff. And so then it just gets more and more general. But I think there's always people who are applying it. And I think that's the one thing that's different about these, the GPTs and stuff, is that it's still very much input output, and the developer is integrating it into something if it's actually getting used. And I think that's just going to be how it always is, where there's developers that are integrating data flows. I just don't see something that's coding itself anytime soon. I don't know, performing actions of its own initiative. Sam Altman, founder of OpenAI, his definition, when asked what is AGI, what's the threshold for you? And his definition is occupies greater than 1/2 of the world economy is maintained by this thing. Which I think from that standpoint, yes, that is going to happen. But is it a thing that has its own Terminator? It's probably less likely.
Interesting. Yeah, it is pretty broad. I mean, what do you mean by occupies half the world economy? And in some ways, my mind goes to, well, what sort of job roles are we talking about here? Because there is a fear that humans are being essentially outsourced by AI and computers, and I think to some extent they are. But what's your thought on that? Is this something that people need to worry about? Like, how does this impact the future of our jobs and our work?
Yeah, I mean, unemployment is at like an all-time low where it was, pre-COVID and everything. And COVID really didn't have anything to do with AI. So, and at the same time, there was all kinds of machine learning technologies being rolled out. Maybe we haven't really seen the full scope of those, but I don't know. There's people developing on DataFlows platform who are making titles for themselves called computer vision engineer. Or the other thing that I think is also a very real factor is there is sometimes maybe some frictions in the economy where people move from things, but like human demand is infinite and AI will be deployed by human intents. I don't see anything in which like you automate things away and then people are like, no, actually we're just bored. We don't want any more things or we don't want more performances or whatever, And that wealth will always keep flowing, especially if you like pair that with like crypto and stuff where, things are moving more liquidly and like, I don't know.
Yeah, I think the fear for some people is my job has been outsourced by a computer, right? We always sort of thought, a musician would be safe, right? They could always perform and make music. And now all of a sudden like, AI is doing that instead. So it's always just an interesting question to sort of ponder and more or less think about the human race, so what is our value? Because, you think about even just 15, 20 years ago or so, there were a lot of people that would be cashiers at a grocery store, for example, right? And now it's just gone to self, checkout. And the next wave of that is just walk out of the store, right? You won't even need to even check anything out anymore. You just walk out of the store. So there's a whole number of job titles here that have been eliminated just because of technology. And, some people are worried about that, I guess.
Yeah, that does make sense. And, in some cases with like a centralized AI that generates an insane amount of value for society, I definitely believe in like UBI. And I was at some of the Andrew Yang meetups in St. Paul and that kind of stuff. So
gotcha.
I'm not saying we shouldn't hedge. I'm not saying we shouldn't hedge against it, but I think it's probably going to shake itself out.
Sure. Have you read his book, The War on Normal People?
I think I did start it. I don't know if I finished it, but
okay.
Yeah.
He paints a pretty dire picture of like what's going to happen and why it's different this time around, right? Because people are like, well, the Industrial Revolution came and, a lot of people moved from an agriculture economy to more of an industrial, world. So there was some retraining that was involved, but there was a place for them to land. He lays out some reasons as to why, we need to have this minimum income for people. But outside of the politics side, it is very interesting. And, my mind kind of goes back and forth every day. I see something really cool. I guess this is a question to you too. Like, what's a cool AI project maybe that you've seen happen recently? But I see something cool that happens and I'm like, oh, wow, the human race is doomed. And then I dig in a little bit more and it's like, no, we're still really far away because the model is specifically trained in one little segment, right? And so the moment it veers off from that, then, a 2-year-old kid could pick it out better than this computer could, right? So there's still a long ways to go. But I don't know, have you seen any interesting projects and anything that either you're dabbling in or you saw in the news that you thought was kind of interesting going on today?
Yeah. So if we want to go into like computer vision projects, I could talk for days. A user made a flamethrowing weed killer.
Oh, nice.
So he's got this flamethrower on this bot and it goes across his lawn and then when it detects a weed, it just incinerates it.
That's awesome.
So that was a fun one, the flamethrower robot.
For sure. Well, yeah, and my background is in IoT. So anytime it sort of involves a product that's using AI and IoT together, it's just like perfectly right in my sweet spot. So yeah. Do you read a lot? Do you have any books or conferences or topics, any sort of stuff you're learning today, either AI or non-AI related, really?
Yeah. I'm trying to read a good amount. I've got various books that I'm working on AI related. I've got this one right here. This one's called I'm a Strange Loop by Douglas Hofstadter. This is the same author of Gödel, Escher, Bach, which is a really good AI book, but it's like 900 pages long. The summary here is that he thinks that consciousness, it emerges from loops in the brain, self-referential loops. And so that's kind of where the Escher stuff comes in, where Escher has a lot of these loops in his artwork. You also see that in a lot of mathematics, like Gödel's incompleteness theorem, where certain things in math could never stand by themselves. They have to, at some point, there's some kind of self-referential loop in logic. This is cool stuff. If you want to dig into it. I don't know what tangible things I got out of that book, but I certainly had a good time reading it.
That's all that's important. Yeah, sometimes you just read for enjoyment.
Yeah, on the softer side of things, I'm reading Day for Foodness right now, which is by Oscar Wilde. He's in prison and he has a lover, Lord Alfred, who's just taken him on such a journey in life. And he's writing about all his grievances, but also continued loves for Lord Henry or Lord Alfred. So it's kind of an interesting read, romantic period side.
I'll put links to all this stuff as we publish for sure. One of the other things I like to talk to people about and ask them is, you've been able to be successful here as you've been working through your career. I mean, any advice on classes people should take? How would somebody new get into this industry or this field? Yeah,
certainly. I do feel somewhat qualified in answering this. I got into machine learning and AI from more or less bootstrapping it. And some classes I found useful was Andrew Ng has a great Coursera class on machine learning. Many people may have heard of it, but if you haven't, you actually do things in MATLAB, I think, and you really get used to how to manipulate the matrices that make up neural networks. And it's a really good way to kind of start learning things. If you want to move a little faster and you don't think you need that you can start to abstract a little bit, there's fast AI courses, which are really good now to kind of start getting your hands on building models in Python and using some libraries that are very particularly tailored for people to get a low floor and then a high ceiling later. And then, just learning PyTorch is another great thing to do. But and then the biggest thing, which is always the best advice, learning how to code anything, is to start a project and, kind of get involved in something that's going to force you to need to leverage different technologies where you wouldn't normally be leveraging those.
Yeah, for sure. One of the things that I tell people is try and find a meetup, try and find a group, and they can be in the Twin Cities, like the Applied AI group that we have that meets the first Thursday of the month, but it can be now anywhere, right? Everything's gone virtual. So there's a great opportunity and looking forward to having you. And I think a coworker as well present at a future meetup here at the Applied AI group, right?
Yeah, definitely looking forward to that. And then, that is a great point in our community that you can find to kind of push yourself forward. That's huge.
Well, yeah. Is there anything else that you'd want to talk about or share with the listeners that maybe we didn't go over?
Yeah, I guess I'd just be curious to cover a little bit of your experience with vision. I know you said you've done some embedded devices. We could get into deployment things a little bit too. And I guess what kind of ways have you leveraged computer vision and some of the work that you've done? And I'd be curious to learn a little bit more about that.
Yeah. Well, we worked with a company that was doing inspection on leather. So we worked with them and again, a lot of these cases are human cases where humans are looking at particular images, and it's very time consuming. It's very boring. It takes some skill to understand where there's holes in leather. The technology is one thing, but it's also just what is the use case? What's the application around it, right? And so if you're making leather, for example, it's okay to have, holes or pock marks in these leather. If it's on the inside of a shoe, for example, someplace you don't see, right? But if you're going to be making a car seat or a couch, you need wide expansive areas that maybe don't have issues in them. And that could be veins. It could be, ticks that are sort of blemishes in the leather. And so right now there's people that are literally at, places where they're taking leather and they're grading it A through F. And it takes a human eye to take a look at it, and they move these leather pieces around. And it's wow, how could we actually have a computer do that instead? Because it's not the best job in the world. I mean, imagine just going there and just carrying these things around, these chunks of leather, and figuring out where they should be deposited. So long story short is yes, in the industrial space, I've worked on sort of train essentially material detection, right? So that's one area. The other area is really around sentiment analysis that I talked about to begin with, where, when someone's presenting at a conference, for example, but now everyone's online, right? Everyone's using Zoom, everyone's using Teams, whatever it is. How can you become a better presenter? By making good eye contact, by using good hand gestures, for example, by smiling. A lot of these companies, you're right, are adding just plugins and stuff that they can add to it. And Ours can be done in real time, but also can be used as a practice tool as well. So people could use it in either case. But, there's so many other places that other people I've interviewed on the program here, everything from medical imaging, right, to finding cancer and whatnot. Those are sort of the ones that everyone sort of reads about, to images as people fly over in agriculture, drones and stuff like that, picking out areas that are either overwatered or underwatered. There's just a lot of stuff you pick out of these images today that the images were not available maybe 10 years ago, or they were very, very costly to do.
Yeah, totally. And then also with the way that AI research has evolved, is the horizon of tasks that you can also now solve is just so much more vast than it used to be. So if you're listening to this podcast and you're thinking about getting started on something, this is like an awesome time to go out and try doing it. Most of it is possible now. So
yeah, I think just sort of off the hip here, a lot of the problems that we have seen, it's sort of like, if it's very obvious, like the cat versus dogs example, like those are super easy, right? With a very small number of data sets or small number of images, you can make that happen. But as it gets a little bit more complex and more difficult, the computer can be really dumb in a lot of these cases. And so the harder the problem, I guess, it feels like the more data you need, because you end up getting all these false positives and all these things that are just not classified correctly. Lots of unknown states that come in. That's been my experience. I don't know if you're seeing that as well.
Oh, totally. Yeah. I mean, it's definitely the devil's in the details, but iterating on the right data, you can usually get to a decent place. Well, that's awesome. Yeah, both those projects are pretty cool. There's some details we could get into.
Yeah, and I guess I would say when it comes to vision, you touched on it a little bit, specifically around like sound waves, right? So I've seen a lot of companies, like we'll take a look at vibration data, for example, that's coming off of a machine, and there's basically sound that can be taken a look at, snapshots. And even when I do some of the audio reviews of these podcasts, it's just me as a dumb human, I guess, can pick out, certain words that people say just by the signature. Images can be applied to audio sound waves like you're talking about earlier.
Yeah, that's awesome. And there's like wave-to-vec. It's like word vectors, except for speech waves, I guess is what it's called. I don't know exactly how it works, but you can make vectors out of the speech waves and have them in a sequence just like you would text. And then you can start to build some models based on that. I don't have experience doing that myself, so I'm not going to try to say more than I know, but it'd be an interesting area to look at.
Yeah, I think I will. Yeah, wave-to-vec. I see it on here. So yeah, I'll add a link to it in the podcast notes. Well, cool. Was there anything else you wanted to chat about at all?
I think we covered a good wide range of things. So this is pretty great.
Good. Well, before I forget, how should people reach out to you?
Oh, yeah. So you can send me an email personally at jacob@roboflow.com. Otherwise, I'm also on LinkedIn, Jacob Solawetz. Yeah, those are probably the two best ways to get a hold of me.
This is awesome, Jacob. Thank you so much for taking your time and letting us know about all the cool stuff you guys are doing at RoboFlow and your background here in this space, and wish you nothing but the best. I'm sure you'll be doing some more and more cool stuff in the future. AI and machine learning, deep learning, all this stuff is it's such a hugely growing field. So many cool areas to get into. So excited to maybe have you back in the future, but we'll be tracking you as you move on. So thank you so much.
Yeah, sounds good. Great talking, Justin. Hopefully you have a great holiday season, and looking forward to seeing you at the meetup.
Excellent. Thank you. Bye-bye.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.